Okay, well, we are talking about graph-powered story worlds. That's the fancy title that I came up with. Basically, my name is Prem. I work for a consultancy called ThoughtWorks. I play the role of tech director, but it's basically a glorified a title for developer, I guess. So I've been helping build this AI-assisted authoring platform for LitRPG novels. Now, if you don't know what LitRPG is, it's short for literary role-playing games. So LitRPG is this genre where characters live inside game-like worlds. They have stats, skills, inventories, quest logs, level ups, all sorts of fancy stuff, all embedded right in the prose. Think Ready Player One meets Dungeons and Dragons. The author writes the story, but they use AI to keep it consistent across a large body of text, and that's the challenge. So let me show you what we did there. So you ask the LLM to provide you with some idea to maybe finish a chapter. You're stuck with something. It happens to authors a lot of times, and it writes something perfectly reasonable until you remember what happened 20 chapters ago. Marcus lost his right arm. The LLM forgot. This isn't hypothetical, okay? It's from a test manuscript that we built when we were testing out the system. So this happens to LLMs all the time. They hallucinate. They make up stuff when they don't know. But that's not great if you're actually trying to do validations using an LLM. So here's why it matters, right? Lit RPG is a genre built on precision. Okay, the readers are absolutely fanatical. They track stats, levels, inventories across millions of words. They'll catch what your LLM won't. Your readers literally have a better knowledge graph of your world than your LLM does, right? So the question is, how do you cope with that? How do you fix that? The obvious answer is that you throw all of it in the LLM's context window. But the research says otherwise, and also our practical experiences say otherwise. Now, coherence, even with an extremely large LLM, so some of these ones from Google and now also Anthropic have million token context windows, and Gemini, I think, has 2 million context window. Coherence drops, at a cliff to with just approximately 5 interactions. Because that's the amount of text that you're dealing with. Only 2 of 9 LLMs, even with this, right? Only 2 of 9 LLMs actually had a consistent worldview, even for those amount of limited interactions. And remember, we are looking at authors working with this for a period of time. It's not just going to be 5 interactions. It's just an unusable system if we just limited it to that. So the point is that attention is obviously not memory. So the other obvious answer is, what about RAG? So here is another scenario. Alina has blue eyes. Alina has green eyes. Now, blue and green eyes land in the same neighborhood in embedding space. Cosine similarity is 0.97. Semantically similar, but contradictory. Right? Now, vector search finds this as relevant context. It cannot find contradictions. And on structured queries like stat tracking, vector RAG literally scores 0. So similarity is not consistency. So we need something fundamentally different. So here's the insight that we had. What if the LLM that knows what's true, when it becomes true, and what rules apply? Not a context window, not a vector index, a knowledge graph. An immune system for your narrative. That's what we bet our architecture on. Let's see how we did. So here's what makes LitRPG the perfect domain for this. The game mechanics are right there in the prose: level ups, stat blocks, quest updates. Regex pulls all of this out at 100% confidence. No LLM is needed at this point in time. Free facts, okay? Because you can do that with LitRPG books because they're written in a certain way that readers expect. So we can exploit that. So basically, every LitRPG novel is secretly a database changelog wrapped in a story. But now let me tell you the full architecture. Of course, if we were just able to use regex, we would not really be talking about this. So yeah, so here is what the architecture looks like. The pipeline is pretty simple, if you ask me. Manuscript goes in, knowledge graph comes out, agents use the knowledge graph, contradictions get caught. Each phase has patterns that we need to solve because obviously the architecture looks simple, but not that simple in reality. So let me walk you through some of these. So we had Neo4j, we had a manuscript. We just needed to put the stuff in the graph. How hard could that be? Turns out the first question is not how to extract, it's what to extract. So what nodes and relationships does the graph need? Or as the graph folks say, what's your ontology? We worked with domain experts to first define a genre level schema, a base schema, the stuff that's true for most RPG books, characters, locations, facts, events, and so on. One important decision here is that facts are nodes, not properties. So we'll see why in a minute. We feed that plus a few sample chapters into Neo4j's schema from text extractor. It comes back with a bunch of entities and relationships. But that's not what the author might be satisfied with. Why? Because it's still using an LLM, and it might not be exact because that's the name of the game, right? But what our experience tells us is that more or less in the ballpark. So what we have is a human in the loop, the author, because they know their book the best. So they take a look at what the LLM has come up with, and now they prune what doesn't make sense, and they basically create what is called the books anthology. So this is really looking at what makes sense in the context of the book itself. Okay. So basically, what you're saying is the machine proposes, the author disposes, and now the question is what exactly? How do we get these facts into these nodes? So now we've got the skeleton. Now we need to actually get facts into these nodes. So here's the thing, right? Here is something that you might see in a lit RPG book. She grabbed her staff. Great, but who is she? That's the pronoun problem. You can't just throw the entire chapter at an LLM and pray. So we solved it in 4 passes, each one feeding the next. So the first pass, like I told you, was to do a quick regex search because it's cheap. You don't have to use LLMs, which means you don't have to spend tokens. And more importantly, the confidence of this process is pretty much 100%. The next thing that we do is we give this gives basically the next step, which is we give this to the standard Neo4j GraphRAG pipeline. Think of it as a head start. Okay, so you've got some entity names, you've got some structured data, even before the LLM touches anything. So that's what we call entity discovery, right? This is roughly what this utility called LLM Graph Transformer, which is part of the GraphRAG package, gives you. You find all the names, or you find most of them. And then pass 2 is this co-reference resolution. Co-reference resolution is just fancy words for trying to grab pronouns and those kinds of things. So she becomes Lyra, the healer becomes Civ, and him becomes Kale, and that kind of thing. Now the LLM knows who everyone is. So the next step is attribute extraction. But now with resolved names, each extracted fact becomes a confidence score. The LLM reports how sure it is, and it does that pretty much everywhere, right? And then cheap passes get fed. feed expensive passes, okay. And the facts are now basically in the graph. Again, I simplify this process. It was a lot more complex, but I've got only this amount of time and real estate on my screen. So more or less, it was what you're seeing here. So now we have got the schema, we have got the data in the graph as well. So the question is what we can do with it. So the facts are in the graph, like I said. Now we need to check what's there. So what we do is we let two kinds of rules, right? So now one, technical users can start writing Cypher graphs, Cypher queries. And they can do that. And we put these as static rules because the administrator has to make sure. So this is the platform administrator has to make sure that there are still certain rules that you need to follow as part of writing LitRPG books. So these are non-negotiable rules, and we don't want to go through this process of having an LLM write some query, although we allow that as an experimentation thing when you're trying to experiment. But basically, we save them as Cypher queries directly. So these are rules which technical users use. Non-technical users, you basically describe a rule that they want in plain English, and then that gets converted to Cypher. And finally, we use that to flag whether a character's eye color changes inadvertently from blue to green or what have you. And then either way, like I said, these rules get saved and then they run against the graph. So now when you're doing that, so you basically are able to flag a bunch of these incoherences, if you will, in the book, right? But these are all static rules, by the way, right? You really don't. The fun of the thing is when you're able to move past that. But some authors are finicky about what kinds of things they want and they don't want, and they want somebody to look over and do that. So this allows both the administrator and the author, both technical and non-technical users, to express some of those constitutional rules, if you want to think of it that way. So another related idea that this allows you to do is a different set of Cypher queries for what you call causal chains. Okay, so what you just saw was that these facts are static, right? Now, but you might want something that is dynamic, like I said. And these are these. Oops, are you able to see it? Sorry. What are you? Yeah, you're able to see it, right? Okay. Yeah, so events are dynamic, right? So and it's usually a chain. So you kill a wolf, you gain some XP, you level up, your stats increase, and you basically see if a reward shows up without a quest completion, the chain is broken. Another plot hole, caught by the same rule engine, right? But authors keep rewriting stuff. They change their minds. So the idea is that we need to keep all of this current. So how do you do that? The graph has to keep up, right? We mark facts from the edited chapter as stale, we re-extract, we then clean up. But the re-extraction step is a bit of a trade-off. You've got two approaches to do that. One is incremental, where you just re-extract the chapter that changed. That's fast, cheap. You do it on pretty much every save. But you might miss some cross-chapter impacts, right? You might have said that this character has blue eyes in chapter 1, and now you might be contradicting yourself by saying, they have green eyes or blue eyes or whatever, right? So in that case, you might need to do full re-extracts. That is a bit expensive because it's usually we are chunking and doing all of that. Even with the utilities that Neo4j provides. It's still 3-4 LLM calls per chunk, and more if your chunk sizes are bigger and so on. But it's guaranteed consistency. You do this at milestones, like you've completed a chapter or you've completed a section or you've done an entire book and that kind of thing. So the graph is really a living document, and you keep it current. Now the question is how do AI agents actually use it? So here is the thing, right? When an author saves, a validation agent kicks off. It does two things. One, the static rules that we just saw, the saved Cypher queries, they run automatically against the graph. That's easy. Eye color drift, dead characters, missing limbs, that kind of things, the known problems. Second, and this is where it really gets interesting, the dynamic query part. Right? The LLM reads what the author just wrote, looks at the graph schema, and then generates its own Cypher queries via text to Cypher. It checks things that you don't think to write rules for, the unknown unknowns. Both layers hit Neo4j. Contradictions come back as inline comments. And then the graph turns 500K words of novel into about 2 KB of targeted context for the LLM. And look, so these patterns are not necessarily limited to just fiction. We built this basically for RPG novels, right? But anywhere content is long-lived, interconnected, and evolving, you basically hit the same problem. So some examples might be legal briefs that reference prior rulings, medical records that span decades, product docs that 50 engineers are editing simultaneously. These days with spec-driven development, that is an unfortunate reality sometimes. It's the same problem and the same solution. So if your system needs to remember, check, or stay consistent in general, you most likely need a graph. So I might make it feel that all of this is child's play, but here are some things that were hard, or that things that we still found hard. Right? One, the main thing was entity resolution. Right? And we had all of this. We had multiple passes at this, and so on and so forth. But it was still pretty hard. Okay. So the healer, Lyra, she, her, all of those things. If you can't resolve those below about, let's say, 85% or so accuracy, the graph is basically full of orphan facts, and everything downstream basically is wrong. So this graph extraction process is definitely one of the most critical things that we had to solve for. And that's why the whole idea of introducing the human in the loop, right? Especially the author. And turns out that the author also relies on this thing where they call them friends and family. Like, these are like fanatics who are willing to do reviews of books even before they are published. So the platform owners might engage with them, and the authors might invite a few select folks to do that. So we do that in conjunction with humans being in this loop. But what you get from the AI is you get a good, reasonable starting point. And you also get a confidence score where the AI itself will tell you that it's only 60% confident because the narrative is fairly complex. Now, we did have to iterate over this quite a few times, right? Because when those rules ran, whether they were static rules or dynamic rules, it was really predicated on this graph. But once you got the graph in a reasonable place, right, then you're really talking. And it was usually tough in the initial phases, especially if you've got a manuscript that is more or less ready. Right now, you've got a very large chunk of text, or if you're writing, let's say, the fourth book in a series, that kind of thing, right, where you've already got 3 books. And it's also a time-consuming thing. So extraction is expensive. So if you're working on problems like this, that's I guess the experts here will agree that that's one of the critical pieces. Obviously extraction cost as well. So the bigger the book, the larger the cost of you having to basically cough up LLM tokens to do that. Maybe right now with LLM tokens being subsidized pretty heavily, maybe we don't really care about that as much. This didn't really come up, but we do keep track of how much we are spending, because if it does become expensive later, then yeah, obviously you need to keep that in an account. So we had a lot of observability going to see how many tokens are getting spent, and also what we did was um, you know uh, as a commercial offering, we were giving these authors a budget, right? Okay, you've got the silver plan, or you've got the bronze plan, or you've got the gold plan, and you get a bunch of tokens for free, and after that you can basically pay for your own tokens if you want to do that. Because we really didn't want authors, or the platform owners didn't want authors to just have the AI write the entire book for them. They really wanted to use it as an assistance mechanism, not a full writing alternative. Another thing is that false positives are annoying. I mean, so LLM does make mistakes, although with the newer LLMs like Anthropic's 4.6 Opus and all of that. I mean, it's pretty close, right? I mean, it does a fantastic job, but obviously you still have the human in the loop. And there are some very critical what do you call corner cases, like you might have a flashback in the book. So just because something just appeared early on sequentially in the book does not necessarily mean. So for example, you've got this thing where you've chopped off your right hand, right? And now you're saying in a later chapter that you're wielding an axe with your right hand. If you just look at it in a plain way, then yeah, I mean, that's a contradiction right there. But if you say that it's a flashback, then it's not, right? So those kinds of corner cases still are a problem, and those need to be taken into account. But it's more or less there. The other thing is syncing during rapid edits. I don't think this is necessarily a graph problem. This was more a design problem that we had, but again, I mean, if you're trying to do this in real time, it was something that we had to contend with, and we had to make architecture. We have to account for it in the architecture. So things like only do it on a save, only do it manually sometimes. Certain kind of checks only do manually because they are pretty expensive, and so on, and do that only at specific milestones and so on. So that kind of thing. So here's the thing, right? The graph really does not replace human judgment. It amplifies it, and that's basically enough for what we were doing. And Neo4j played a huge part in the solution, and that's why this talk. I'm happy to take any questions you might have. Let me know if there are any, and yeah. Okay, I'm trying to read what's. There's question. Oh, Q&A tab. Okay. What do you use for entity extraction and entity? Oh yeah. So yeah, there isn't a whole lot. We had to write some custom stuff for that. The main thing that we did use was the schema to, I forget the name, schema to text transformer, or something like that. I forget the exact name, but that is something. And then there was one more thing as well, as far as what do you call, as far as entity extraction, there is a Neo4j utility. I forget the name right now, but give me a second, it will come back. Yeah. So there is this thing called LLM graph transformer, which might help, but there is nothing for. So that does help a little bit in terms of discovering entities, but there isn't anything that we could find for co-reference resolution, attribute extraction, and so on and so forth. That was something that was directly usable. So we had to write a bunch of those, but we were using LangGraph as our AI framework. So that was that. Any other questions? Marcus, looks like there might not be anything else. If there isn't, then I guess we're done. Do I leave stage? Is that what I need to do? Sorry, I'm not familiar with this platform. Perfect. Thanks a lot, folks. It was great being here, and hopefully you picked up a couple of things. And see you around next time.